Hello and welcome back to a new video here on the Lötwig Fusel channel. Now in last video in our Boundless 2D Game Engine series we transformed our code so that we are now based on a application. So actually if I close everything here, the only thing if we are writing code for our engine, if we are actually producing an app, which is something that we're gonna do in the end of the day, if we are writing an app for the engine, a game, whatever, probably later on also going to be more specific for games and other types of apps. But in general, if you are doing a normal application here in the engine, you're going to have these few code modules that are defined. Main is in the future going to be a completely auto-generated register as well. And then you just have your application that has functions defined, that also have a few events that you could listen to. And you're going to have implementation that's going to contain the code. But currently you can see that there's something missing. You can see that we do not have command line arguments, which is not good. So I think we need to fix that. So how are we going to fix that? Well, we have a problem because we can have normal char and we can have W char. So how am I going to fix that? Well, the fixing of that is going to actually take a bit longer. Now, first of all, let's start simple and go to the emsys. You can see that we have a main application here, and what we now need is also arguments for the main application. So how am I going to name this class? Well, I'm going to name them main application arguments, because there's going to be an interface and there's going to be an implementations. Actually, let's call this just main application arguments .h, and let's put everything in one header. So if I take a look at this, you can see it's in the namespace BL2D. We're going to do this as well, and I'm going to call this class main application arguments. This is going to be the interface where everything is based on, and then what I'm going to have is I'm going to have another class based on a template, on a type name T, which is the class main application arguments, but described at this. So this is kind of like the idea. We have a interface and we have the arguments as a class. Now how does the interface is going to work? The interface is basically going to work as always virtual destructor, just to make this all compatible and not going to fall apart. And then the interface is going to define all the functions that we need to retrieve arguments from the application. Now, what the application is then going to implement, or the implementation is going to implement, it's going to implement the actual storage type. So this is going to be a public main application arguments. And this type is now going to be char or W char. So we could use type traits. Let's first include like string, and let's include type traits, and let's do a quick type name equals std enable if t, std is same, std is, there it is same v, so if it is same, if t is the same to char, or if t is the same to w char. This is kind of like the condition that I want to be able to do. And then basically what we're going to have is we're going to have a bit of a storage in here. For the storage, I think I'm going to use vector and unordered map. Vector and unordered map. I don't think that we really would need a vector. We could also get away with a list. Let's use a list. But vector is a bit more easier iteratable. I don't know. Let's use vector. I don't know. Let's go for it. So what I want to have is I want to have an std vector of std basic. Basic string, because basic string is basically a string based on a type. So std vector of a basic string of type t, and this is going to be the positional arguments in there. Now what we're also going to have is we're going to have a std, I think I included map, no, unordered map, I included the proper one. Unordered map, I'm going to have an unordered map based on basic strings to basic strings, and these are my named arguments. So I'm going to have normal arguments that are based on positions, and we're going to have named arguments that are based on a name. So what we need is we need a bit of a retrieval function, and what we need is we need to have a way of actually getting access to these. So the interface, how am I going to do this in a proper way? I think I'm gonna have another interface, a main application argument proxy. So we have a proxy on how to access a single argument. Now this is kind of like a list of arguments. This is a single argument. And this is kind of like a proxy that allows you to kind of like access the element itself. So basically how this shall work is that you can gain access to a proxy. Of course, if we're having a proxy, it's going to be a bit of a problem. But it's not going to be too big of a deal. Basically, these are the functions that are going to be supported. I want to have a std basic string view, or let's do an std string reference as string. This is a interface that shall be supported. Virtual as string, which is not implemented, and then we have a sw string. These are like two functions that we're going to start with. Maybe let's remove the s and just say string and w string. And these are the first two functions that we can start with so that we gain access to these. And basically what I want to do is I think I want to have two implementations of the proxy here. How am I want to do this? Yeah, I think I'm going to have two implementations of the proxy. But the thing is that implementations of the proxy is actually going to be inside of here. We're going to have, I'm going to put them completely to the bottom or not. Let's put them to the top, right? Let's put them to the top. And we're going to have a public class S proxy, which is going to be the, let's call it EQ proxy, the equal proxy. So if two objects are equal, we're going to have an equal proxy, which is a public... no, actually, I don't want to have this. I want to have a vconvert proxy and an aconvert proxy. A vconvert proxy is going to be a public proxy, and the aconvert proxy is going to be a public proxy. And one of them is converting to W strings, so it's a W converter and an A string converter. So W strings will be done with that proxy, and AQ is going to be for that. And what we're going to be is we're going to do a we're going to later on see how we're going to implement and how do I want to go into that. I think maybe I can go with templates there. That's a hard thing to do, because I think maybe we do not want to go this proxy path at all. Okay, now maybe let's make this simpler. I don't want to make it too complicated now. I need to think if I make this as a proxy later. Let's start by just being able to return strings. So what I want to have is I want to have a virtual std or virtual const std string reference get function. Get string. Let's call this one get string, and we can either have it as a positional or as a const std string, which is returning a string. How did I? Let's just call this one string. So we can either get it by a position or by a name, and then we can have the same one for W strings. And let's call this one W string, this function here. And then we can kind of like give it a name as a W string. And now we just need to implement the functions in our actual implementation. And this is going to be basically implemented with custom string conversion. I need to think on how we probably going to do this, but let's first start with the actual constructor. We're going to have argc and argv in here, and let's first construct them. So first of all, I need to iterate over all of these arguments. Actually this is going to be a t pointer for int I equals 0, I smaller, argc I plus plus. Let's iterate over these. Now first of all, I want to have a delimiter. Let's maybe using. Let's not do it with. Let's hard code the delimiter for now. That indicates if it is a positional argument or a named Now basically, how shall a command line look like? A command line should look like that. Name.exe, then there is like the positional 1, positional 2, then there is a dash nm, and then is then the nm value. Basically, this is how named argument shall work. So let's maybe call this nm value. This is nm true, so this is basically just true. No, actually, I don't think that I want to support these. Then positional 3, like this is the idea. You're always going to have a dash, and then it's kind of like a positional argument. I might want to think maybe we want to have positionals just as true. This is like nm true, and this is like nm value. Let's maybe do it like that and make things a bit more flexible so that we can supply like values or normal just positional ones that are gotta be true. Alright, so how am I gonna do this from the implementation? So first of all, I'm gonna check if my argv add position, oops, I didn't want to open that, add position 0 is gonna be a dash. Then it is gonna be named. Else it is gonna be positional. That's the whole story of that, and I think this is a kind of unsafe, so we do actually need to check. No, I think the first one is always safe. The first one is safe because it is either the null terminator or a dash, so this is actually fine. This is named, so basically what I want to do now is I want to store this into a string, so std basic string of t arg is equal to argv I position 1, so the next character, and then we have arg, and then we need to kind of like position that. Positional arguments are easy. Positional arguments are just a pushback of argv I. That's simple. And what I now want to do inside of here is I want to find, so what is arg? Why is arg a pointer? It's not a pointer. Why did you try to sell me a pointer there? I don't know. Basically find first off, so I want to find the first equal sign, and this is the outer position, the eq pos, and if eq pos equal std basic string npos, so no position found, then it's named true, else it is name value pair. So we have a named argument, and the named argument is true, which basically means that my named arguments at argument is gonna be equal to 1. Or how could we make this? This is not portable. Also, this is not portable because it's a char. But I think we could get away and say this one at 0 is equal to, I think 64 is like A. But I think it's fine. I think it's fine to actually, yeah, I think if we are doing it with chars, then it's actually fine, because these ones are normal ASCII chars are convertible to W chars without issues, because they are like same. Oh, and 49, yeah. I think this one is definitely fine, so we're gonna basically say, yeah, but this one doesn't really work. I first need to assign it to a new value, so basically I'm gonna say your basic string to clear it. A basic string of type T, this shall clear it, new std basic string, like that, and then we can set data. Let's maybe do it differently. data, and then we dereference it and set it like that. Then we just need to make sure that we resize it. Let's do it like a auto ref arcs equals to that, and then we can say arcs, and we can reference arcs then. Oh, come on. Dereferenced arcs data is 1. Arcs dot. I don't like it that I don't have IntelliSense available. Provide sample template. Let's quickly do char. It doesn't work. Nice. But the idea is, I think, the resize or the resize function, std string resize. Oh, this is the wrong C++ that I wanted to have, is like n and char. I can directly. Yeah, okay. Then we go for resize 1 and 1, but I do need to set the data anyways to make sure that it's 100% correct. I think this should give us something. Now the named value, it's a bit simpler, because I basically now need another string, or actually 2 strings. Basic string t, which is the arg name, is equal arg sub. No, just substring. I want to start at 0 and I want to go to the equal position -1, right? And then I'm gonna go for the std. Now let's copy it over. And then I want to start from the equal position, and this is the arg value. And then I'm gonna say that m named args that arg name equals std move arg value. So now I have the arguments in here. So this should be a very basic parsing code. Of course, if these functions need to be implemented or it doesn't work, even though I might first wanna look that everything is good. So let's quickly just add a return. Actually, I don't think that I need to return at all. Maybe it doesn't compile, but I think I don't use them. So maybe I can get away with not but I think I need to, because it's the vtable. The vtable is a problem. Yeah, okay, but why not? Why not just quickly implement this? And I forgot the const there. So let's add the const in here. Let's add the const in here. Let's add a const in here. There. Then what we can do here is we can return positional arguments position, and names we can also just return. So auto it equals named arguments find string, and then I say return dereferenced its second. Should be fine, I think. Same goes for W string. The only problem is that now W strings are not going to work. We need to have a bit of a conversion in between here, but that's not a big deal. We're going to have the conversion in a second. Let's maybe just say, no, I think I'm going to start with W strings. So actually, W strings are the ones that are more working now, and these ones can just do a static std string s and return s, which is not nice now, and we do later on need a conversion between them. And this is something that we still need to come up. Basically what I need to do is I also need to generate another type that is gonna be basically the other one of these. So I do kind of like gonna have a using, but I want to first get to there and see that it works at least in this way, and then we can adapt it. So where is this going to be used? So first of all, the main application. Come on, ANSYS. Come on, give me my intelligence back. Main application arguments. There it is. And then I can put it in here into main application arguments, reference args. Or actually it's not that, it's actually the iMain application arguments that I want to have. And actually I want to have them const. And maybe even in the BL2D namespace. So that I can populate this forward to the dummy app. Or what I could also use, because I think if I remove the namespace here, it is getting problems. So let's go in here and let's do it like that. Let's say using iMain arguments to that, so that this alias is a bit better. And then if this is aliasing better, come on, alias, there it goes. Then we have a better aliasing in here. I can put this into run, and we now have the arguments, and I can now make a breakpoint and see if they have been parsed correctly. And what I could do is I could also quickly print them, right? Currently iterating over the named one is not possible. I also don't have size bounds, and maybe we need the functions to check if they exist at some point. But I think for now it's actually fine. So what I want to do now is I want to go inside of my booting code, inside of boot.h, no universal, I think, boot.h, because in the universal the arguments are passed on here. And basically what I want to do here is I want to include them. So let's go in here. And let's add the arguments as an include. And I don't know why my IntelliSense is completely not liking to highlight stuff. Risk and solution. I shouldn't need to do this on a per project base. Risk and solution. No, it's basically just, yeah, not working. But what I can do is I can do a BL2D main application arguments of type T called args, build those argc and argv, because this is now aliasing good, and we can put an args in here. And now everything falls apart, probably. Yeah, fade. Okay. So this needs to go in here. Named arguments not found. Named arguments find. Let's see. Let's quickly recompile it. I don't know. Maybe it is probably not that issue, but here map traits compare. Yeah, okay. I cannot see what it is. T is char. Why is T char? T should be W char. Right? Why are you instantiating this with the wrong type? Why is it for going for char and not W char? I mean, yeah, I can't convert. That's what? But it's a CDW string. Interesting. Basic string from T. Why is it compiling for char? It should not be compiling for char. Teacher. Because it compiles both times. Yeah, okay. I see the problem. Because we are having two instantiations in the char main and W char main, it's instantiating it twice. We can get quickly away with it by Returning, doing a static stdw string s and returning s here as well, which is a fine code for just verifying that everything else is working before we can work on getting string conversions done in a proper way. Error? Still error? Why? That requires a... Ah, okay. Template argument list. Okay. But this should at least parse strings. Hello world. It works, that's good, but I don't see if it does really work. We do still need to go into my dummy app and make a breakpoint here to inspect what's inside of that. I'm in development, so args are probably not here. Oh, they are here. No named arguments, but one positional argument, which is the path, so that's already good. But what I want to do is I want to quickly go to debug. Again, just to see this a bit better, and what I want to do is I want to quickly modify my debugging path here. Debugging and the command line arguments. So this is position 1, then we have nm hello, or let's call this one nm1, so let's call it A. A is hello. Then we have position 2, position 3, and then we have B equals to world exclamation mark, then position 4. That's kind of like the arguments that I want to quickly have. Now, of course, I've set them up not correctly. Let's make them for all configurations here. All right, and let's see how they are being processed by the application, if I made any mistakes or if basic string is still possible. So now let's see, positional arguments, position 1, 2, 3, 4, they are in there. Named arguments is just the last one set. So there's a problem with named arguments. And I think we not even covered all cases that can happen. So a case that could also happen is like if B would just be true and if then we would have C, something like that. That is more or less how we would check if that works. Let's see if the other one, the one that's just true works. So actually you can see that B to 1 works, but the other ones does not. So this doesn't work. Arg name, arg value. Why are they not working? Let's make a breakpoint here and see. The name is empty. And the value is equal hello. Okay. So it needs to be exactly the other way around. I always get them wrong with substrings. I'm not good at substrings. I would probably be better at doing a regex than a substring, which would be not even that big of a deal or that even a bad idea. But yeah, now they should work. Positional 1, 2, 3, 4, they work. And named, we have A hello, B1 and C world exclamation mark, so you can see that the arguments are parsed correctly. Now we just need to have a way to get them out of the container. And this is now where strings are getting in our way. We do not have proper handling of strings and string conversion. So that's something that we need to implement, and that's something that we're going to implement into a util project. And I don't think that I want to add it now, but we're going to add another one in here to API boot IOC and MSys collection. That's going to be util, and this is going to contain a few util functions that as a static library are just linked together with everything that do not really contain functional code, just like static library util stuff. That's kind of like the idea. Everything that's like static library, that's not like on a certain library base or on things like that. Maybe it might be on a library base, but on something that's really cross-platform and cross-platform available, and not really as a code module. Something like UUID generation, string conversion, all of that shall go into a util package. And I think we're gonna leave it there for today. So thank you for watching. See you in the next video. Make sure to like and subscribe, and have a nice day. Bye.